moderating our first session, as well as welcoming you to our Cloud Infrastructure Summit, Public versus Private versus Hybrid, brought to you by Nutanix. The editorial staff of Redmond Mag, Virtualization and Cloud Review, and AWS Insider.net have worked hard to bring together some of the best independent experts on this topic. So we really hope you enjoy it. Before we start today's event with these three great sessions, we do have some announcements. First, we want to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Each of today's three sessions will be followed by a 5 to 10 minute Q&A. So please be sure to put your questions into the Q&A area of your console so we can get them answered for you by our experts. During today's third session, we will be giving away a $1,000 Amex gift card, but you must be present to win. So be sure to stay on for the entire event. Finally, we do have resources from our sponsor, Nutanix, available on the console right now. So please download and check those out. It's because of Nutanix's underwriting of this content that we can bring you this summit. So we thank them for sponsoring and supporting the community and ask you to check out these resources so we can bring you more events in the future. Now on to the first session of today's summit, Public versus Private versus Hybrid, the State of the Cloud. This session features Greg Schultz, founder and IT analyst, Server Storage IO. Greg has worked as a customer in various IT organizations in different roles, as well as a vendor, consulting analyst, and author of several books, including Software-Defined Data Infrastructure Essentials. Greg brings a diverse background with real-world perspective across applications, data infrastructure, hardware, software, and clouds. Greg is a Microsoft MVP Cloud Data Center Management and previous 10-time VMware vExpert. Take it away, Greg.
Great. Thanks, Chris, for that introduction. Hello and welcome, everybody, to our first session today as part of the Cloud Infrastructure Summit. I'm Greg Schultz, as Chris mentioned, and we are going to be talking today about public versus private versus hybrid, or we could flip those around, private versus public versus hybrid, any combination. But what it really comes down to, it's the state of the cloud, what can you do today, and we're going to talk about the public cloud, the private cloud, hybrid, some different things in between. And also, what's best? That's a common question. What's best for yours or my particular environment? Anyway, let's get started with this conversation about public versus private versus hybrid with a little bit of a step back. Here's the thing. The big picture, data infrastructures. Data infrastructures are what exists to support business applications, to support that transformation of data into information and make that information usable across different application landscapes. And the data infrastructures are comprised of the hardware, the software, the services, the best practices, the tools, the policies, the techniques. They comprise from servers to storage to I/O networking, software from operating systems, hypervisors, container management, and databases, repositories, all different things. And the key point in all this is that the data infrastructures are what exist inside of physical facilities, whether they be your own data center or computer room, whether they be at a managed service provider, a colo, a telco, whether they exist within a cloud, the public cloud or elsewhere. The data infrastructures are those components that sit inside of somewhere that span from the core out to the edge. And it's those things that comprise, that are used to build what we often call just infrastructure, but it's that infrastructure optimized for the data, for that processing to support that information. Key point here, we're going to keep seeing these multicolored bars over on the right that go vertically, as well as down the bottom that go horizontally, because it's to emphasize this is a multi-dimensional model paradigm, if you would, that things extend across the core. They extend out from the core, whether it's on-prem, out to a public cloud, but that there's also different layers. lower level infrastructure as a service, platform as a service, and software as a service. And as we go, we'll keep building out on this. But part of this notion is that we do have these different layers. Down at the lower level, the virtual machines, the containers, storage, networking, compute, moving up that stack, that we go up into platforms as a service for delivery or other apps that can be used to build even more functionality, higher up sorts of things. And that we've got these different layers, these different elevations at different altitudes or focus area. So when we're talking about clouds, particularly the state of the cloud, it's what's your focus area? Is it horizontally, from out at the edge, or is it on-prem or at a public cloud or semi-public? Or what's your focus that elevation-wise, that stack layer? Is it lower level? Is it medium level? Is it that higher level, software as a service, Office 365, Salesforce, Box, Google Drive, Google Docs, among many, many other different examples. So as we start to look at that, we have these different considerations that come into focus. It's not just the cloud, there's all these instantiations and variations in different focus layers of that cloud. And that management is what comes into the very, very important aspect to this, is how are you going to manage in a particular cloud? How are you going to gain that insight, that awareness, have that situational awareness of where you are, what you're doing, how things are being consumed, things being the resources that are part of that data infrastructure. How is your service delivery? How are the apps performing? How are the apps that transform that data into information working? How are you orchestrating? How are you facilitating security, backup, data protection, the networking, service, and cost monitoring? So these are all parts of this, and this view, again, I want to emphasize is that we want to be looking that horizontally across one dimension, but also up and down that stack at various levels, at various layers, or altitude if you prefer. All right, so common question is, right, we want to go from on-prem to core to edge to public cloud. What's your focus? What are you doing and planning on doing? So often it's like, well, what's the best cloud, Greg? Well, it depends. People they say, well, no, tell us which ones. Well, it depends. What are you trying to do? What are you trying to accomplish? What's that outcome? What's that business objective, that enablement, that IT service delivery experience? What is it you're trying to accomplish? And that's why we have to step back, which is look at some of those parts of that data infrastructure. And again, keeping in mind that data infrastructure is what exists and in one way provides all those cloud services. In another way, it's how you assimilate those different resources to deliver a higher up application. So we know there's compute, storage, I/O, networking, hardware, software, management, which we touched on already. But what does your on-site, what does your on-prem data infrastructure look like today? Maybe you've gone all in, all cloud, and have eliminated your on-prem. Well, have you completely eliminated your on-premise, your on-site data infrastructure? In other words, is there no networking? Is there no local file caching or file servers? Has everything moved to the cloud? Maybe you're at the other extreme, which is that you've only got a little bit in the cloud today. Maybe you're just dabbling, which is great. Both points, both perspectives on a timeline like that are fine, as long as they align to what you need to do as an organization, what you have to do to focus on the business. So how are you using cloud today as part of your data infrastructure? At what layer, at what level? How are you managing today your on-prem versus your different clouds, and how will you manage, or are you managing today across those different layers, horizontally as well as up and down vertically? And what are your objectives for enabling hybrid cloud, and as well as your resources, your workloads? So something that comes up often is this debate. Is it public versus private versus on-prem versus hybrid? Well, Sometimes people get bogged down even just on, is it on-prem or on-premise or on-premises? All right, if you got a lot of time to go off on tangents like that, that's good. But it should really be, how can these different instantiations, how can these different ways of having your data infrastructure to support your business, how can they work together? So in some cases, it can be a one public versus private versus hybrid. But another way of looking at it is public and private and hybrid. How can they work together? How can they enable your organization, your IT, to have it your way, to do what it is that you need, what you want to do, versus how somebody says this is how you have to do it. It's one or the other. No, it can be a as a part of, or an and. So, are you under mandates to do something? In other words, where and what are your focus area and options? Are there any mandates or requiring? Do you have to do a cloud first, a cloud native? Why? Well, because somebody said we had to. Is your focus on that infrastructure as a service, that lower level, or the middle layer, platform as a service, which could also include development tools, development environments, or that higher up, that software as a service, that Office 365, that Salesforce, the Adobe, the Teams, all sorts of different things that are up there. And what are your financial and cost considerations? How will you, or are you managing your clouds? And what are your staffing considerations? So often, let's go to the cloud. Why? We're going to save money. Okay. Then all of a sudden, somebody comes back and says, hey, we seem to be spending a lot on clouds. We're not quite seeing the savings. Well, part of that can be because you're using the clouds. You're doing more. They're easy to use. They're easy to provision. It's easy to get a server or a virtual machine or a container. It's easy to get something developed or deployed quickly. Well, yeah, that's going to cost you. But there's still these staffing considerations that go into it. So as we continue our journey, let's take a look at a couple other things, some big picture common challenges, which are budget constraints. Plain and simple, budget constraints. We know there's growth. We know there's more happening. But there's budget constraints around the cloud, the software spending, associated staffing, both for initial deployment but also recurrent management as well as training. Growth, look, here's the thing. There is no such thing as a data or information recession. Okay, there are tight budgets, there are spending constraints, but when it comes down to it, we're seeing new applications that generate and process and move more amounts of data. The data themselves are getting larger. We look at videos going from what was 1K to 4K to 8K and beyond, but also going from 8-bit to 10-bit video. So we're seeing the data volume itself getting larger, as well as more of it, and happening at a faster rate. And for multiple locations, from mobile to edge, work from home, as well as at the core. Then we're also seeing these new emerging tools, technologies, and trends, coupled with security, data protection, compliance, and of course, are you under a cloud first or a cloud native or other mandate? And then there's something that for some people it might be new, but for others it's deja vu, which is shadow IT, business units that are off on their own. They're doing their own apps. They're doing their own development work. They're doing their own clouds. And at some point, somebody shows up and says, hey, you're going to take care of this now. IT has just absorbed this. This has been put on IT's doorstep. Take care of it. What are you going to do? Well, you want to be prepared. Don't be afraid. Be prepared. So with that in mind, let's keep going here and look at some things tied to this whole public versus private versus hybrid, or public and private and hybrid. So with that, a couple of things here. Hopefully this is somewhat familiar, but if we look at it from the standpoint of you've got legacy on-prem or on-site or on-premise, whatever your preference is, you could have containers, virtual machines, bare metal, physical machines, different layers of software, different sorts of server storage, I/O networking hardware and software that could be talking to public clouds, or you might be working across multiple different public clouds. But one of the things I want to point out here is this notion of intra-cloud, i.e. intra, in other words, moving stuff within a given cloud. For example, moving things within AWS, moving things within Azure, moving things within Google, or whoever your cloud provider of choice happens to be, that you might be moving from US East to US West or one region to the other, but you're still intra-cloud. You're inside that particular cloud, that particular public cloud. But then there's inter-cloud. Inter-cloud is you're moving things from AWS to Azure, from Azure to Google, from Google to your on-prem. And it's a really simple nomenclature, and now you think of it. There is the internet, when you're communicating out amongst different networks, different locations, different domains, different areas, but then you also can have an intranet within your organization, within your domain. Well, the same thing applies within clouds. There's intra-cloud, there's inter-cloud. Intra-cloud, you can have intra-region. In other words, moving things within a given region. Inter-region would be moving between US West and US East, but you're still within that intra-cloud. Hopefully that's not confusing, but it's a way of keeping perspective and looking at and keeping things in mind. Now, also keep in mind, we're going to reinforce this, that we've got that horizontal, that's the locations, where things are per se, different services, different platforms or regions. But we also have to keep in mind that vertical, from low level to high level. All right, so which is best? Depends on your environment, your organization. It doesn't have to be a one-size-fits-all. Everything is not the same, so why treat everything the same? So we've got public cloud, various geographies, scale is needed. They can be across different regions, data centers. There's a lot of resilience built in. Pay for what is consumed, offload your internal data infrastructure, and as needed to cloud service providers. And then there's a lot of different offerings at different layers, at different cost points. And that's probably the thing about cost is make sure you're comparing apples to oranges. It's really easy, and we'll touch on a couple of these as we go. But for example, when you're looking at cloud storage, make sure that you're looking well beyond just the cost per capacity, that you're also looking for that cost of service capability. It might be very, very low cost capacity, but its performance might be slower than, well, keep performance, keep other attributes in mind. Same thing with compute, same thing with network. Keep all those in mind. Private is that you have an on-prem or at a managed service provider or colo, but the key is that it's similar to a public, but you are in control. You have complete control, complete management of not only the service that's being delivered, but the underlying components. Maybe you have, as a part of being at a colo, somebody else who's physically taking care of things that need somebody physically to walk up to your cage or up to your servers or do whatever. But everything else you have control over. Multi-cloud is that you are using multiple different clouds from different providers, that you've got things spread across AWS, Azure, Google, among others. Or that maybe you're using some portions of, say, AWS for microservices, and that maybe you're using Azure for data protection, and maybe you have certain kinds of apps running at Google. So you might have things spread around based on functionality, resources, preferences, mergers, acquisitions. So hybrid is the best of all worlds. It can be on-prem with legacy and private. It could be public. It could be multi-cloud from core to edge, all points in between. And the thing about hybrid is it's flexibility. The good news is you've got a lot of flexibility in terms of resources, vendors, how things are, but there's also that caveat that you could have some cost increases because of complexity tied to management. So it's a balancing act. And again, keep in mind that this can be that one versus the other. sort of discussion, but it can also very much be a this and this and this, and we'll look at some pros and cons as we go here as well. All right, so continuing on. So with this notion of having those different layers, having those different altitudes, having those different points of interest in the stack, here we see that. And again, we see the vertical over there on the right, but we also see that horizontal going across the different layers. So with that in mind, we can look at a couple different things. So what is that example of the SaaS? It's the software as a service. It could be that Office 365, Salesforce, Google Drives, Google Docs, Teams, among many, many different options that are out there. Then we also have things like PaaS, that platform as a service. That could be databases, SQL and NoSQL databases or table stores. It could be something like a Tomcat environment, Tanzu, Kubernetes, other orchestrations. It could be something like a Facebook, but using APIs to go in there and do some things programmatically with an existing tool that you can actually put your own front end on in front of. And then infrastructure is that lower level, the fundamental building blocks that other things are built upon. And that's the thing to keep in mind, is that it is a stack, it is a layering. And where's your focus layer, what are you doing, and how do they tie together? How do they work together to enable and deliver your information services for your business? All right, so where are you on your cloud journey? For some, it's a cloud is a destination. For others, it's an operating consumption management model that it's just a current place where your data infrastructure, your app infrastructures exist, where they're being managed, where they're being delivered out of, which could change over time. Some people ask, what's next with clouds? Well, we're seeing that right now is that evolution from public to private to hybrid as well as multi. Again, have it your way. How do you want to enable it? How do you want to use it? But think of it this way, is if we look at this, where is your organization at? Where are you and your organization going with all of this? In perspective of different layers across different points in time. Well, what I've broken down here is that on the left, we've got some different models: hybrid, public, private, all on-prem with some cloud, all on-prem, no cloud. Different organizations are going to be at different points just within those different layers there. But as we look across horizontally, how are you using, for example, private cloud for infrastructure as a service, as platform, for a SaaS, for legacy development, for production, for DevOps or data protection or other things? Or likewise, how are you using hybrid or a public? So this you could use to actually just assess your environment today. Where are you at? Just fill in that in to how far are you? For example, are you 100% infrastructure as a service in a private or in a public cloud, but with nothing in other categories? Or are you X% in hybrid, X% in public, some private, as well as having some legacy? So this is just a way of looking at this picture and going in a little bit, having a little bit more of that insight, that awareness of how is your organization using clouds in general, and then start to look at that is that how do they compare? Where does it make sense to be? Because again, that data infrastructure is that notion of how are you going to compose those different resources into a service that can be delivered for supporting your apps and your business. So what are the best ways, what are the best resources that you can do that and do that effectively? And how are you doing it today versus tomorrow? All right, so we've talked about management. We've talked about cloud management. Let's just revisit a couple of different things here. So with the cloud management, how will technology adapt to your business and application needs? Now, one of the things that is fairly common is, how do you adapt your business to the cloud? Well, that to me would say that cloud is not very flexible, because it should be the other way around. Whichever approach you choose, public, private, hybrid, multi, legacy, the technology should adapt to your business needs. Now, granted, there is business transformation, the whole digital transformation shift, bringing in new apps, new functionality, doing things in new ways. That is a part of that shift, that change, and that the technologies can help facilitate, can help enable that, and in some cases help push that. But the resources, those data infrastructure resources, whatever that layer happens to be, wherever it happens to be across that horizontal timeline, they should work for you, not you working for them. Okay? So in other words, recurring theme, keep those different layers in perspective. Are your application cloud native, or are you rehosting? What's your distance in networking, your effective bandwidth and latency needs? What are your security and authentication granularity requirements? Where is the workload? Where are the apps? Where is the data, as well as where are the users? How is maintenance going to be done? Updates, remediation? How are you going to handle costs and the networking egress cost as you start to move things around? One of the things with the cloud providers is that, yeah, give us your data. We'll take all of your data. We'll ingest it for free. Bring it. We can take care of it. Well, if you're not aware, where your costs start to add up real quickly is when you want to move your data out of AWS to Azure. When you want to take it from Azure and move it over to Google or move it around, that's where you start incurring some interesting costs, which, if you keep those in perspective, that's what you want to keep in mind. So don't be caught off guard. Go in eyes wide open. And I guess something else here to add is your security, data protection, backup. But watch out for vendor lock-in. All right. Some say go to the cloud. We'll eliminate all our vendor lock-in. Well, we could change it and say watch out for cloud lock-in. Well, how would you do that? Real simple. Same way you became locked into vendors back when you were on-site, on-prem in the past, is that you've become tied to a particular technology, tool, feature, capability, something that ties you to either that vendor or their technology. And the same thing can happen very easily in the cloud, in that you go into the cloud and you start to use extensions that may be unique to that particular platform, that particular service, that particular functionality, that particular cloud provider. And before you know it, all of a sudden, you've become locked in. So you want to be aware of that. But here's the flip side to that. Again, this is one of these, or it doesn't have to be a or. It can be an and. Lock-in is not bad. Yes, I said that. Lock-in is not bad if it enables you, your organization, to accomplish something that any potential lock-in is offset by that benefit that you've achieved. But as you start to move into a more of a multi-hybrid environment, you want to look at tools, technology, particularly in the management space, that allow you to look across, horizontally, across those different providers, locations, localities, but also to look up and down that stack, up and down those different elevations, and have those different functional viewpoints. That if you're in security, you can see things bigger and broader than just a focused security domain viewpoint. If you're in the compute side, you see what's causing all that workload to come on. You're in storage, you're seeing things that are doing more than just taking up space or causing issues. So it's giving you that broader view, that broader insight, to have that situational awareness so that you're not flying blind while you're in your clouds. So a couple more things is knowing your business, knowing your application, and their workload requirements. That includes the data and the infrastructure resource needs that they rely upon. How's your cloud resources being used today? Are you overspending or underspending? And this is a real mixed bag. There are some organizations that may be overspending. Somebody's out there, they're spending things up, spin up a new virtual machine, spin up some new containers. They're really moving forward with cloud native, spinning up apps in record time, a lot of resiliency. But maybe instead of buying shots, so to speak, small consumption on a large scale, that they need to shift those microservices maybe into a bigger mode of consumption. In other words, move instead of running as a microservice, for example, on AWS Lambda, maybe moving that to your own Kubernetes cluster that you're either managing with AWS or Azure or some sort of cross-platform tool, where now you've got more economies of scale because you're doing more microservices. Maybe even you're looking at doing microservices containers on bare metal because you're doing it at such a scale, you want to take a hypervisor out. There's a lot of points in between, but it's being aware. How are those resources being used? Are you delivering service to what you need to, or are you delivering services based on cost cutting, or are you underperforming? That there's apps that could perform much better if they were given more resources instead of cost cutting. So it's a balancing act. Everything is not the same. Watch out for treating everything the same. And that gets into those metrics, different metrics that you can look at, your RTOs, recovery times, RPOs, recovery points, mean time of repair, service levels, things like that. But again, up and down that stack, but also looking at things from a compound perspective. In other words, is your RTO, is your resiliency just for the storage or just for the network or just for the database, or is it for everything that relies upon all those resources working together? What are your metrics? How quickly are trouble tickets resolved? So automation is key to a lot of this, but automation is only as good as the timely data feeds that it gets, that it needs for making that informed decision making. Without that, it's garbage in, garbage out. So again, this is that role of having that good telemetry, that good information as to what's going on. And how well do you know your cloud cost? When was the last time you looked at your invoice and wondered, are we overspending? Are we underspending? Are we leveraging discounts? Are we prepaying so that we can actually commit to a particular vendor? That doesn't necessarily mean locked into them. Yeah, you're locked in for that service life or whatever that is, which is similar to like leasing a car or leasing a building or something similar to that. For the duration of those terms, yeah, you have a commitment there. But it also gives you that benefit of not having to pay full walk-up, full retail fares or prices to get some better discounts. And leverage those, again, back to the metrics, having that insight. Again, looking up and down that stack, depending on where you're at, looking up, looking down, what's the cause and effect, but also looking at that outcome, looking at what's being powered, what's being enabled, that you might be spending and the financial people say, yeah, you've got to cut your budgets. Well, great. Maybe to send a message to them, now take this with a grain of salt. What I'm about to tell you is you say, fine, we can cut some costs. What happens if we cut the financial people's and all of a sudden their apps slow down? They're going to be the first to complain. What did you do? Why did you do that? Well, you told us to cut costs. I don't recommend doing that without a conversation. But that's the key. Have a conversation with the higher-ups, with the business representative, with the different organizations. If the financial people are telling you got to cut costs, get their fingerprints on the decision-making. Make sure that they understand that for every dollar you spend this way that you're achieving this, they may surprise you and say, well, what if I can find you $2? Can you make things twice as good? Okay? It also gets into that discussion of needs versus want. I want this. Great. Can you pay for it? No, I want somebody else to. Versus I need this. Well, if you need this, you can then help cost justify it. And so often, because there's not that conversation of needs versus wants and what's that cost ramification, It's a really powerful tool, a capability, a discussion point. And what will happen is a couple of things. One, I've experienced this where when asked and explained, why do I need to spend this? Yeah, I've been offered more budget to go do things. But on the flip side to it, somebody might say is, well, you know what, this is good enough. Well, they might be leaning towards that underspending until you can help them realize that it's an investment. It's not just about spending, unless, of course, you've got resources that aren't being used, that you're spending for containers that are running, the containers that are out there that are provisioned, virtual machines, storage, apps, whatever, that you're paying for seats, you're paying for software licenses that aren't being used, all right? There's that opportunity to do some cost savings versus simple cost cutting. All right, a couple more things here as we look at that is part of that initial and recurring, whether we're public, private, hybrid, all the above, is designing management and maintenance up front into whatever your architecture is going to be. How are you going to do your policies, your procedures? How are you going to handle remediation, updates, troubleshooting, performance, capacity monitoring? How are you going to leverage automation and different orchestration control plane tools? And again, that all ties back to having that awareness, having the information feeds that are real time, that are timely, that are accurate, that are reflective of what it is that you're looking at. And as you go from a private or from a public to more of a hybrid or a multi, that tool, those technologies, your dashboard, your displays, your alerts, your detection systems need to be able to get those feeds from different sources and to be able to handle and work with those. So what about licensing costs? I just mentioned this, I touched on it. Let's just look at a couple different things here. Are you able to use your existing software licenses within a cloud? Do you need to have new software licenses? Are you paying for software licenses that are seat-based, but that they're just not being used? So there's that opportunity to go in there and revisit, relook at things, and see where you can reduce some costs, remove complexity, remove some overhead, invest where need be, save where appropriate, but also the right size. So again, look at different things, leverage the different cloud capabilities. Many of the providers have tools that give you that ability to look and do a self-assessment. So data protection. Data protection, some would say, well, geez, we don't have to worry about that. The clouds are very resilient. They are very durable. They're very available. Well, what level of granularity and where within those stack layers you need to do protection for? So this is about different levels of granularity, different layers. What is it that you need to have, particularly as you go across different environments? So there's different technologies, different tools, there's different locations. What is it that you need to protect the business, the applications, the information, that data infrastructure? What granularity, what layer and frequency, where to protect and where to recover to? So there's a whole group of tools, technologies over on there on the left, but over on the right are some of the questions of where are you going to apply them to and for what right there in the middle. Everything is not the same. Don't treat all your applications and all your data infrastructure needs the same. And just a couple more building out here. Again, this is all being recorded, so you can come back and look at some of these, but it's just going in a little bit deeper and looking at having different resilience, different retention. Again, that focus up and down that stack, up and down those layers. So here's an example, real quickly, that looks at multi-cloud, hybrid cloud, public, private data protection. And it's really about protecting in various locations for different things at different layers. In that it could be protecting on-prem to a cloud, it could be protecting from within a public cloud, doing an intra-cloud to another region. It could be inter-cloud, where you're protecting some AWS to Azure, or from Azure to AWS or Google, whatever it happens to be. It could also be where you're protecting all your O365, your Salesforce, your data from another environment where you're protecting that, say, to a different cloud. Why? So that it's not a matter of if something happens, it's when, that you're prepared, that you're ready. It could be replicating from on-prem to a public cloud or across public clouds, either inter or intra, doing things with virtual machines or with hyper-converged infrastructures, taking different software stacks that are now running on top of different clouds. It could be a lot of different things. What is it that you need to do for your backup, your data recovery, business continuance, and resiliency? All right, let's start to wrap up here. We're going to start our landing. We've been flying around in the clouds. Here's something to keep in mind. Head in the clouds, your vision and strategy, feet on the ground. You're planning, you're implementing, you're managing. Don't be afraid, be prepared, do your homework. Expand your tradecraft skills, experiences. Learn adjacency technologies. If you're the server person, you better know about storage and networking, software, not just about virtual machines or just containers or OSs. Likewise, if you're one of these others, if you're in security, you better learn about these other adjacent areas. And for all the different disciplines within the data infrastructure that it combines, you got to be aware of your adjacencies. To the side horizontally, up, down, vertically, and including what's going on with the apps. Learn about the different tools and technologies when they fit to meet your needs. And like today, attend these different sessions, go back, listen to the replays, and know what you have, where you're going, and where you've been. So it's that balancing act. Head in the clouds, feet on the ground. All right, let's wrap up. Everything is not the same. So why treat it the same? Gain and maintain situational awareness and insight. Know your business and app requirements along with your workload profiles and the resources that they need and depend upon, as well as what you're spending on. The best solution is the one that works for you and your organization. Cloud should be an operating paradigm, not necessarily a destination. And again, keep those different layers that we've seen, that icon on the right, keep those in perspective, while also across the locations, where we saw that bar across the bottom horizontally. Where to learn more? My site, storageioblog.com. My books, you can also find them at storageio.com, but various books, software-defined data infrastructures, which goes from legacy, on-prem, private, public, multi-cloud, have it your way, virtual machines, bare metal, containers, database tables, a lot of different things in there, from performance, data protection, a lot of different stuff in there, as well as some of my other books. Anyway, you can see there my email contact. So with that, we've got time here for a few questions.
Okay, great. Yeah, you ready, Greg?
Absolutely, Chris. Let's go for it.
Sweet. All right, first question. What are some examples of cloud lock-in, and how can we avoid it?
Yeah, it's one of those where the easiest example would be, without naming a particular vendor or platform, is that you're doing, whether it's storage or a virtual machine or even a container, but that you're really leveraging in their service and you're leveraging extensions that make it very difficult to just pick up your apps and move them somewhere else, okay? That there's some extension, some hook. It might be for a management purpose. It might be for provisioning. It might be a special functionality for analytics, for machine learning or something that you just become hooked into.
Okay. What is the difference between intercloud and intracloud?
Yeah, that's a good one. You know, we talked about it, but it's a good refresher. When you think of something as inter, inter is across, inter is a cross thing. So in other words, intercloud, say, for across AWS to Azure. Intra is within. So like intranet is within your organization, within your domain per se. Internet would be across different domains. So intra-cloud is within your cloud environment or within a given provider. Inter is across. Inter would be saying multi or even hybrid.
Okay, and for our audience, don't forget to get those questions in. We just have a few more minutes with Greg. Mark just sent one in. Any white paper on in-house cloud versus public cloud that you recommend?
A lot of different ones that are out there. There's some platform-independent ones. I may have some on my site. I know I've got them in my books. But if you're looking more white paper, just probably do a Google or a Bing or DuckDuckGo, whatever your preference for a search engine browser. Just put a search in there. You'll find the theoretical ones like from NIST, but then you'll also find some generic ones, and you'll also find a lot of the vendor-specific ones. So look at them all and take them and put in perspective and ask that key question. Okay, great. How does this apply to me? How is this going to help me versus me helping somebody else?
Okay, Quinn wants to know, what are your thoughts about multi-cloud architecture?
Yeah, so the whole thing there is, what is it that you're trying to accomplish? Are you trying to adapt to an architecture, or are you trying to architect to what your business, your organization needs today as well as for moving forward? So the one is that here, we're going to take our business, our organization, and we're going to stuff it into this multi-cloud architecture template guide, whatever, okay? The other is, all right, these are some interesting architectures for multi-cloud and at different layers. How can we apply them to our environment?
Okay, here's another great question. Is it possible to design and implement applications so that they are transparently transportable between multiple cloud environments?
Yes, with the caveat is that you keep them portable, that you watch out for dependencies, okay? So, and again, dependencies can be okay, but you just need to know about them. That if you're doing something, so for example, you're building a microservices container-based app, which should be very, very portable, which by themselves, they can be very portable. But if you're using some hook, some call-out, some feature functionality that's unique or has a dependency, you need to know what that is and how can that dependency either be abstracted, isolated, or that it can be brought along with you. If you know about it, you're ahead of the game, so that you're not just shifting from current tech debt to establishing new future tech debt.
Okay. What consideration do we need to make for making our deployments cloud agnostic?
Yeah, there again is watch out for doing and using anything that ties you, for example, to Azure or to AWS or to Google, whatever that might happen to be. Some might say, for example, well, if you write .NET, if you're leveraging .NET, you're tied to Microsoft. Well, do your homework, because you might find that there are either runtimes or capabilities across the different clouds that allows you to move your .NET-based apps around without being tied or being convinced otherwise. But it can also go the other way, is if you're on that leading, bleeding edge, if you're going to say, write a WebASM app, is, okay, when you write that, what are the libraries, what are the hooks, and do the different providers allow you to deploy that, and with what caveats? So go in eyes wide open.
All right, great advice. Do VMware and other hypervisor solutions run on virtual machines when running public clouds?
Good question. So there's this myth or perception that if you're running in a public cloud and you've got compute, it's all virtual machines. Well, the major cloud providers have bare metal machine or metal as a service that things like a VMware or other software can actually run without having to run in a nested, virtualized type environment.
Okay, looks like we have one more question for you. Doesn't Kubernetes eliminate vendor and cloud lock-in?
In theory, yes. But there again, it comes back to that caveat is there's so many different variations, different vendors who have their Kubernetes published, packaged kit. What hooks do they have? What are you leveraging that may or may not be supported as you move across? So in other words, it may not be the Kubernetes that's going to lock you down, but how you're building it, how you're managing it, what extensions, what features are you putting into it, or that somebody is putting into it for you, that when you go to move, it's like, something just broke.
All right, that looks like that's all our time. Thanks for the talk, Greg.
No worries, Chris. My pleasure. Thank you, everybody, and look forward to the rest of today's sessions.
All right, everyone, stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day. Pain points, when to consider switching or evolving your cloud architecture. Take a chance to check out those resources by Nutanix, and we will be right back.
Thank you. Welcome back, everyone. Thanks for rejoining us after that terrific first session from Greg and Chris. And of course, thanks to our sponsor today, Nutanix, for underwriting all this great content. My name is Gladys Rama. I'm the editorial director here, and I'm so pleased to moderate the second session of our Cloud Infrastructure Summit, Public versus Private versus Hybrid. This second session is called Pain Points, when to consider switching or evolving your cloud architecture. Our speaker for the second session is Joey D'Antoni. He's the principal consultant at Denny Cherry and Associates Consulting. If you tune into any of our other summits, you're probably well familiar with Joey's background. He's a VMware vExpert and a Microsoft Data Platform MVP, and has over 20 years of experience working in both Fortune 500 and smaller firms. He's worked extensively on database platforms and cloud technologies, and has specific expertise in performance tuning, infrastructure, and disaster recovery. And incidentally, he writes an awesome column on redmondmag.com if you're able to catch it. It's called Joey on SQL Server. The monthly column, and I just have to plug it because it's that great. All right, go ahead, Joey, take it away.
Thanks, Gladys, and welcome, everyone, and I hope you're having a nice summit today. This was a cool topic. I was happy to kind of get to share it, because one of the things I find challenging, and we work with a lot of customers, almost all the customers I work with now are pretty much in the cloud, but I work with some customers who aren't. In changing strategies and changing your architecture, it can be something that can happen suddenly or it can happen dramatically. But one of the things that I think drives this kind of change is organizational challenges, right? Typically, we're not going to up and change running systems that are successfully, in a good state, just because we decided to. It's going to be some business driver, whether it be an acquisition or your business environment changing. Maybe company was acquired and you had a sudden change, or you're making a digital transformation. And this typically happens when your leadership wants the business to be more productive. I see some organizations are definitely way more advanced on how they're using automation and how they're using data than others. The other aspect of this is there are new technologies that drive innovation, right? And this is honestly probably one of the biggest drivers of cloud architecture changes, just because what happens over time, even though your system's running fine, and especially when you're using something, maybe a little bit more cloud native than just using VMs, those platform as a service offerings that Amazon, Google, and Microsoft provide, those evolve over time. And what was, the best solution for you 6 months ago may not suddenly be the best solution now. One example of that is recently Microsoft introduced Postgres support for its Cosmos DB database. Microsoft also has another database service called Azure for Postgres SQL. But Cosmos brings some additional things to the table. So that new support might be one of those examples of a new technology that leads you to make a change. But to drill down a little bit further on organizational challenges, or is to use terrible Microsoft corporate speak that I have once heard, to double-click on organizational challenges, I will not use that. I'm using it ironically. Your management can have unreal expectations of the cloud. This happens really commonly. I think it's a little better now because more organizations have experience with it. But there was a time where people who were all in on the cloud, and there's nothing wrong with that, think it's going to be cheaper, faster, better, automated. And if you haven't seen the bumper sticker that says the cloud is just somebody else's computer in another data center or something like that, well, that's kind of accurate. There's a lot more to it than that, and there's a lot of really good things about the cloud. It's not magic. You still have to get your data there. You still have to have your stuff architected in a way that it's going to perform well. It also costs money, and that's something that can also be a big challenge. One of the common cost problems I see with a lot of customers is the overreaction to the first cloud bill. One of the kind of interesting things about cloud spend is that you're consolidating a number of different vendors that you used to pay into paying a single vendor. So, for example, you had a storage vendor that you bought storage from. You had a server vendor that you bought servers from. You had a network vendor that you bought switches from. Additionally, you had other pieces of software that the cloud may provide. Maybe you had monitoring and alerting software that you're switching to, built-in solutions in the cloud. Not all of those things cost money, but some of them do, and some of them are kind of unpredictable. Like one of the common pain points is downstream bandwidth, especially with AWS, where data moving between VMs, data moving from the cloud to on-prem, that's all metered, and that can cost a lot of money. And it's somewhat unpredictable until you've been operating a couple months and have a decent idea of what those flows are going to look like. So one of the things, and you want to be a little careful not to just up and change everything, is if your management does overreact at the first cloud bill. The other thing is your management may not understand the challenges of shifting to a cloud model. And really the challenges here are largely, they're like 5% technical and 95% organizational. And by organizational, I mean you want to have people who have the skills that can manage your cloud or skill up your own staff. And that, especially in a larger IT organization, it can be very challenging to either hire enough people or skill up those folks to get the skills they need. One of the common things I always talk about is networking with cloud, right? One of our consultants who works with this is a business intelligence developer, and she's really, really good at being a business intelligence developer. She knows a lot about databases. And we've jokingly called her the senior network engineer, because it seems like in almost all of our business intelligence cloud projects, we end up having to do pretty hardcore networking stuff just to get everything talking to all the other stuff. And that networking stuff is somewhat built into each service, so it operates a little bit differently. So you kind of have to understand how storage service A works with database service B, and how you need to make those things talk. And there's a lot of nuance with that, and you don't necessarily get that in a training course until you really use it. So getting those people skilled is always going to be a hard thing, and you're going to deploy things inefficiently, and you're going to spend too much money initially. These are all things that most organizations do. It's just something to be kind of aware of. And then finally, bosses are going to boss. I think we're kind of observing a lesson in terrible management going on at a large social media company right now, or probably two large social media companies right now. Sometimes your management's going to have completely unrealistic expectations, and there's nothing you can do about that except look for another job. And in that case, cloud skills are very valuable, and it's pretty easy to transition. If you can manage your manager, which is always a good skill to have, to kind of maintain their expectations, that can be very helpful. But don't just try to let them overreact to completely irrational decisions. So some of the other triggers for change, and it's kind of funny because I was working with assessing someone's application recently for kind of a major re-engineering of their application, and we were taking a couple of different approaches. And some of these can be, or common, your business model changes. So maybe one example of this, and I'm actually in Vegas right now because I'm speaking at a conference, and I'm going to be talking about this in a session later today, was a customer we had where they had their business model, their business is selling data to customers about, I'll just leave it at selling data. They sell enriched data. And one of the things we were able to do for them was they were shipping their data in all these various like CSV, TSV, all these kind of old school formats and FTPing it to their customers. So very, very, 1990s, 2000s technology. And this was in 2015. And one of the things we suggested they do, because what most of their customers were doing were simply ingesting that data into databases, was to provide a database to their customers. So they could just have a database with that data in a structured format. They could add some additional intelligence. They could sell value-added services. And we were able to do that. And we built, really changed their business model by doing that. And that was kind of my coolest cloud change story, because I think it's really interesting. Another thing that can happen, and this was something I was working on last week, is you can take on a giant new customer. We have a client where they're going to have a customer who's bigger than all of their other customers combined, which means the transactional loads on their system are going to go way up across the board. This is a big deal. It's actually causing them to re-architect their app, and it kind of ties into the next part of financial situation, and it's not so much a financial situation. It's they actually can't buy bigger hardware than they're on right now because they're in a cloud, and the configuration that AWS offers is the largest they'll support for that image. So they have no way of scaling up right now. So that's something that's a concern for them. So when you do that, that's when you maybe evaluate looking at your architecture and seeing if you want to maybe bring some stuff back on-prem, and I'll talk a little bit more about that later. Or you want to re-architect your application in such a way that it just scales a little better. And that's really the scale thing is what we're always looking for. If you can design things in such a way that they scale out rather than having to buy more hardware, especially when you get to the upper end of the hardware spectrum, it can be way more cost effective to have a lot of small boxes that do things, although you kind of have to design for that from the beginning. Next, your financial situation changes. It's a common one, and this a lot of people took advantage of this early in the pandemic where, they weren't selling as much stuff. Like I know of a fitness-involved fitness/gym involved company where they weren't selling as much stuff, so they kind of downsized everything they did in the cloud. That can be a trigger for how you change things, especially to reduce that run rate. Alternatively, if you start being really successful, we have that term cloud repatriation, and this can be one of those cases where it makes sense to bring stuff back on-prem and buy hardware potentially. And then finally, your CTO read an article on Facebook. I was writing this presentation on a plane the other day, and we always used to say Airplane Magazine, but those don't really exist anymore. So I substituted Facebook for the Airplane Magazine. But yeah, your management can get whims and encourage those changes, and that's typically not the best way to have a trigger for change. But sometimes it can get really interesting. So next, I wanted to talk through some of the more common cloud design patterns that we see across a number of organizations. And we'll kind of go through each of these in a little bit of detail. Lift and shift probably being the most common one, and it's definitely the most common one that organizations start with. It's very, very rare that an organization will just re-architect their application in order to move it to the cloud. Typically, they're going to take it, take the VMs that it's running on, and then move those VMs to the cloud. It's not the most cost-effective way to necessarily do a cloud project, but it is very straightforward and minimizes the number of changes you will have to make in order to make things work. Generally, you might have to make some minor network changes and understand how storage works, but outside of that, it's VMs or VMs. Next, there's serverless, and I kind of hate the word serverless in and of itself because, you're running on a server somewhere, but serverless apps kind of mean a lot of things, but typically they represent scalability, low infrastructure design. So it's kind of a design pattern that works for some things, doesn't work for everything. Microservices-based architecture, also popular in the news lately. This is where you have, single services for various things on an application. We'll also talk specifically about cloud repatriation, and this is just when you move stuff that you had on the cloud back to on-prem. I think the most famous example of this is Dropbox, who repatriates a lot of stuff, repatriated a lot of their cloud presence to reduce cost. We'll also talk about multi-cloud, the pluses and minuses of why you should consider it and why you shouldn't consider it. And then finally, kind of one of my favorites, and this is a little bit deeper architecture, is queuing architecture. And I specifically wanted to bring this up because queue architecture is typically at the heart of systems that sell tickets. And we've had a recent controversy with one Ms. Taylor Swift, whose concerts were far too popular, and Ticketmaster kind of melted down. It also had some downstream impacts on other ticketing providers too. So we'll explain how that works and how that can melt down. So lift and shift. This is by far the most common design pattern. I do see a lot of organizations that end up kind of in a hybrid lift and shift serverless model, because serverless can be fairly easy to adopt for some applications. But as you go into the cloud, lift and shift is by far the easiest thing to do because you're not changing your application. Hopefully you shouldn't be doing anything to your application code. If you have third-party applications, this should be no problem. They all support running on cloud VMs because cloud VMs are really not fundamentally different from VMware or Hyper-V VMs. And this is typically done on an application-by-application basis, these migrations. There's always a kind of, we like to call it the really expensive period, where a lot of organizations will end up running in a data center and then side-by-side in the cloud. So they're paying for two sets of workloads. Costs tend to be relatively high for these lift and shift models just because larger compute VMs tend to be expensive. So if you have pretty large workloads, and I'm really glad as mentioned, I do a lot of work with SQL Server. My SQL servers are really guilty of this because they have a lot of hardware resources. We have a customer that has roughly 50 terabytes of SQL Server in a single couple of instances. That's not good, Joey. In two instances that are in an availability group, so they're clustered together. And their VMs have like 1.75 terabytes of RAM each. So those are big machines. And the list price on those is like $27,000 a month. They have a discount plan and the reservations and things like that. But the cost for those large workloads is relatively high. The level of complexity here is low. So this is the reason why so many organizations have to choose this when they get started. The only changes you kind of have to make, storage is typically going to be a little bit different in the cloud, but there are vendors who will help you with that too. So if you have a particular SAN vendor, you might want to talk to them and ask them what their cloud offering is, because one of the things the storage vendors have started doing is offering their storage or their storage services on the public cloud, which means you don't even have to change the way you interact with storage, because typically in the past you had to either use managed disk from Azure or EBS volumes from Amazon, and you had to understand how those worked and how you got performance out of them. So there's that. The second part that you can't avoid completely is networking, right? So the networking is going to be different. If you use Cisco, Meraki, or whoever on-prem, you're using the cloud-native networking that's there. You can use some of those third-party firewall devices and stuff for some specialized network use cases, but in general, for your basics of your networking is going to be handled by the cloud provider. And each of those are slightly different in subtle ways, so that's something that's important to keep in mind. Serverless, and I kind of define serverless as moving to flexible resources, and I like to think about things that auto-scale. We have, in all these various cloud services, I think the things we started with that were serverless were really all functions as a service. Amazon has Lambda functions. Azure has, they're just called Azure functions. I don't know what Google calls theirs. And these are arbitrary bits of code that just run without actually having to be assigned any piece of physical hardware. You can buy hardware, further complicating this. But the goal of these is to reduce your costs and make your apps more performant. This kind of does fall in line with a little bit of a microservices model. But we have serverless at lots of levels too. So, for example, Azure SQL Database is a serverless option where it will auto-scale and auto-pause when unused to reduce your cost. So one of the things about a serverless architecture is if it's well-designed, it can be more cost-effective than running VMs all the time. But it's not for every pattern because sometimes these serverless solutions have wait time. So if you're not running them all the time, they have to warm up. For example, the Azure functions, unless you buy dedicated capacity, you're going on to shared hardware. So you do some queuing initially, which means your code isn't like instantly executed. Pick your patterns appropriately. This is kind of, a lot of customers I see use serverless to kind of glue their VM stuff together, right? So they'll have a bunch of VMs and they'll start to be like, hey, we're in the cloud. We can take advantage of some of these novel features. The important thing to finally to understand is the cost of these solutions. And as I mentioned, their performance. The cost then can be a concern because typically they'll cost a little bit more per time unit. And what you're paying for there is the flexibility. So a lot of times if you have something that has to run all the time, it can be more cost effective to run it in not necessarily an auto-scaling mode and pay for dedicated resource capacity that you may not otherwise have. That's kind of the key aspect of this. The other part of serverless that's good to keep in mind, even if you're not a developer, I know I kind of honed in there on function as a service. There are a lot of no-code or low-code solutions in the space too. So you can take advantage of, specifically in Azure, it's Azure Logic Apps. I don't remember the Amazon solution that's like that, but you get a GUI for building an application. You have a trigger that can be time. It can be a file. It can be an email. And then you'll take some action based on that. And it's a really cool way to build some automation into your cloud platform, even for just basic kind of admin tasks. But for sure, if you're building applications that run your business, it's something that you can take advantage of. Just be careful with the cost and be aware of the performance. You'll figure out the performance pretty quickly. So microservices, this is a solution that's frequently associated with containers and Kubernetes. So microservices just typically means you're going to have a small service that's going to run with to support a very specific business function. For example, search might be a microservice or your transaction handling. Typically, each of those microservices is going to have like a front-end container and then a back-end data store container. I did say data store. Typically, that's going to be a database, but in some cases, it may also have a cache. These microservices are apparently unpopular with some bosses who think they know more than the engineering staff. But one of the cool things about them is they can allow apps to scale better and be more reliable. If anybody's a system admin or a site reliability engineer, I highly recommend reading up on microservices. There's a book from Google called Site Reliability Engineering it's an O'Reilly book, but it's written by people at Google. There's also a book called Distributed Systems there that talk about like some of the fundamental concepts here. And you build these microservices in such a way that even though they have dependencies on other microservices, that they shouldn't fail completely if those other microservices go away. And that's where you're taking advantage of things like queues and caching so that you can stay alive while other services go down. It also allows more and faster development because you can kind of be independent, and the whole containerization of things kind of helps with that too, because it becomes easier to isolate workloads. And the cost of scaling up kind of additional compute is less, right? If you have to build a VM, somebody has to get an operating system on it, even if it's coming from an image, you have to then get your application software there, and containers just makes all of that a lot easier. It can greatly increase the complexity of applications, so that is something to keep in mind. This is not for the faint of heart. If you have a team, and I've seen this happen at bad consultant engagements where like the team had 2 developers and they wanted to implement a microservices architecture. That's not going to work. It's definitely not for everybody. If you buy most of your software, you're not going to be doing this. But it is a very powerful solution. And like I said, those books I recommended are a great place to get started on understanding how that kind of stuff works. So cloud repatriation. This is less common, but it still happens. And I do have a number of good friends who work for storage vendors and hardware vendors, and they do see this in larger organizations. But where it tends to happen more often is rapidly growing software as a service organizations. Let's face it, building data centers or even renting data center space is still really expensive, and it's hard to do. And that's a lot of what we're paying for when we pay for a cloud. We no longer have to worry about getting network bandwidth to the data center. We no longer have to worry about securing the data center. Those are all your cloud vendors' concerns. And obviously, if you're building something like a software as a service application, you're probably not going to have the capital up front, especially in the current VC market, to build something in your own data center. You're not going to go out and buy servers and rack them and worry about having a second data center for disaster recovery or anything like that. So as you grow a business, so think something like Uber that started out very small, or really any of the apps we use that have grown very quickly, those will start out frequently being built on the cloud, but then as they grow and become very successful and they have that capital, then if the cloud represents a large line item in their spend, it can make sense to bring that back on-prem, just because they might be able to do it more cost effectively. That's really kind of the main reason. That big line item is a big concern. I know of a cloud database vendor that exclusively runs on the cloud, and they're one of the ones who doesn't own their own cloud. So that's always been a concern with me from buying stock in that company, because even as they grow, they're giving. I know we talk frequently about the Apple tax. In that case, there's an Amazon and Microsoft and Google tax for that vendor because they have all of their stuff is on those clouds. So as they're more successful, they're going to have to pay those clouds more. Sure, they might be able to get better discounts over time, but that's something that's always going to be a concern for them. But so on-premises can be more cost-effective. One of the things when I was an architect at Comcast, we used to buy servers, and we bought so many servers that we were able to have reverse auctions. So we bought 1,000 servers at a time. And so we would just put out a bid with the spec of server that we wanted. And the vendors would give us a price, and it was a really good price in terms of what we needed. And that was like our cost-effective way of buying servers. We were able to do the same thing largely with storage, where we would put out a spec and get a storage vendor to support it. So if you have the right people, but you need to have a lot of those people who know how to manage data centers, it can be more cost effective. The other thing you have to worry about, and this is something that I haven't done in a long time, is, what happens when the red light goes on the hard drive, or a server dies, or a network card dies. So you have to ensure that you have robust hardware and support. One of the ways a lot of customers I see that have quote unquote gone back on-prem is they've gone to like a bare metal hosting provider, so somebody like Equinix in that space, just because they wanted the raw performance. Ideally, repatriation is just effectively a reverse lift and shift. So you can do this with minimal changes to your application in most cases. You might have to update your DNS settings, and that's really about it. It should be pretty straightforward. Multi-cloud. And I chose a dirt cloud here because for the image that I wanted to use on the slide, because multi-cloud is something that's hard. It's not really a technology problem. It's really easy to get, the cloud providers talk to each other with VPNs and networks and such. I even know of a financial services organization that has a data center that's in between Amazon and Microsoft data centers in Northern Virginia. So they have basically their own cross connect between the two clouds. So the networking aspects and getting it to work is relatively straightforward. But really it's a people problem, not a technology one. We talked earlier about how hard it is to staff up your IT organization for supporting cloud, even something like a lift and shift. Now double that, because you have to have people that know both. And while there are a growing number of professionals who do know both, and I count myself in that number, I don't know Amazon as well as I do Azure. So I'm always a little double checking myself, and you might want to implement one design pattern that might not be as efficient on the other cloud. Pricing, especially for very low level things, is different. So the high level things is pretty much the same. Like a given VM pretty much costs the same on each of the clouds. But as you get lower into the stack, like network traffic and things like that are all priced slightly differently. Frequently, when your organization is multi-cloud, this happens inorganically. So it's through acquisition, rogue IT groups. And when I say rogue IT groups, I don't really mean IT. I meant, some senior VP with a corporate card. So that's something that can happen. There are some monitoring tools that will let you look at your network to see if people are using cloud resources that you don't know about. A little bit harder in a work-from-home model, but something to keep in mind. If you design for multi-cloud from the start and have the right people, you can make it work. The biggest design challenge that I see is you have to choose a cloud home for your application. There are some things that I think it makes total sense to go multi-cloud for, one of which is backup protection. I think having that segregation is really good. And moving storage around is relatively straightforward, and the backup vendors will support you on that. But having planned automated failover between clouds just isn't something that's going to happen. There's too much that has to change. And like I say, when I say home cloud, I mean, where are your DNS settings stored? What's routing the traffic between the two clouds? So you're going to have a single point of failure somewhere. So nothing's perfect. The final thing I'll say about multi-cloud is the other aspect that's driving, and there's a lot of regulations. I know in financial services, a lot of, not necessarily in the U.S., but a lot of EU regulators are not wanting to have a single cloud as a single point of failure. So they're requiring businesses to use multiple clouds, which good luck to them, because it's a challenge. So queuing or asynchronous architecture. Synchronous processes have limited scale. As a database administrator, I know this very well. While you can make databases perform very well, not everyone does. Just for an example, I was working with a gambling site at one point doing some performance testing, and they were able to process just over 13 million transactions per second on a single machine. They also had some of the best developers I've ever worked with. Most organizations do not have those developers. So synchronous processing has limited scale because you have things like locking. You have to write the transactions to disk. These are all super challenging. So asynchronous architecture uses a queuing model, and it's typically called event-driven architecture. And you have a queuing layer where the events come in, and then they wait until we'll just say database is available, and they can process. And this is a multi-layered solution because you're inherently introducing multiple tiers into your application. And scaling writes is always hard. A thing that a lot of people ask for and want is a globally distributed database that's a single database where you can write anywhere. The issue with that is if you write to a distributed system like that, you have to have a mechanism for doing conflict resolution, whether it be last timestamp or anything like that. And ultimately, the process of doing that conflict resolution is more expensive than doing the writes. So you end up with like a very high load on your systems. So scaling writes is always kind of challenging. So you have to come up with some other way to design it. And what happened with Ticketmaster the other week, they haven't published a postmortem or anything, but I think basically their queuing system is actually pretty good. It usually works. In spite of what I think about Ticketmaster as a company, their technology is usually okay. But I think with the Taylor Swift concert, it just completely overwhelmed even their best laid plans of a queuing system for how they were going to protect, how they were going to sell those tickets. And now they're probably going to have to deal with a bunch of lawsuits and stuff, so not fun. But anytime you're building a customer-facing application that you anticipate is going to be pretty busy, you want to think about how you're going to build that queue, and you also probably want to think about how you're processing those writes. So like if you can build that to scale out across multiple databases, typically that's something you have to design from the very beginning of your application before you write a single line of code. You want to think about that though, because it can be a really effective way of making sure your application can scale to the degree that you need it to, so Taylor Swift doesn't bring your company in the news. As an IT administrator, you never want to be the reason why your company's in the news. So some of the challenges around all of these things, change is really hard. Even just something as simple as a lift and shift requires a whole bunch of change. You have to get, a number of people involved. You have to get application teams involved. Gladys mentioned my Redmond MAD column. I wrote one a couple of years ago about migrating a customer to the cloud, and we had two major systems that were moving for them. One was a group of systems that drove their website, and then the other was a group of data warehouse systems that drove their back-end infrastructure, but really built the company's data that was their business value. I had two teams that I was working with. I kind of designed the architecture for the whole thing, but the website team decided they wanted to save some money and go with a different VM that I didn't recommend. And they also went with like a different storage architecture, which was all fine. The problem was they didn't really test. So I had observability and stuff, and I could see what was running. And during the testing phase, there were barely any activity on the server. And we got a couple of like anecdotal reports about, performance being bad on the system. And so I added a couple of indexes and did some things like that. But nobody actually really tested it to see what was happening. Queue go live. So as soon as they go live, performance is awful. We were on a call like overnight trying to get it working. And I think I transitioned to Denny, who's on the West Coast. I was on the East Coast. And by the time I woke up, it was still going. And I said, hey, what if we switch to the VM type I recommended? And they're like, do you really think that'll do anything? And I'm like, I don't know, but nothing else is fixing it, right? And sure enough, as soon as we switched, performance was perfect. It was an issue with like multi-threading or something like that, as I recall. And so that kind of change is really hard. The other team, just to give you a point of reference, they really did test. They ran their whole processes in parallel. When we cut them over, it was on a Sunday, and I'll kind of never forget it. I was flying to Los Angeles, and I was recording some training the next day. And I was really worried because I didn't have any emails. Nobody had called me, and I wanted to make sure like everything wasn't down. So I called, and they were like, no, everything's running fine. They never even needed to call me for the cutover. So planning is by far the most important thing, and of course, testing. Governance is next. I didn't talk a lot about governance today because I usually feel like I talked about it too much. But having things like naming conventions and policies and restricting who can do what is really important in the cloud because it really helps you control cost, but it also helps you know what resources are where. So managing those costs, and this is something that's really important in the cloud, mainly because there's a single bill and your bosses see it. Your cost and your architecture are the same thing. If you have poorly designed apps, they're going to be expensive. If you have to buy massive VMs, those are going to be pricey. If you're moving tons of network traffic in a way that's really inefficient, that's also going to be pricey. If I see your cloud bill, I can usually tell how your application's built. I can see the services you're using, and I can then kind of describe to you what you're doing right, what you're doing wrong, where your inefficiencies are. So it can be important to look at that and to keep that in mind. And I never want to say look at the most expensive thing and then cut it down because that's not the way you do cloud economics. But look at the most expensive thing and say, why are we using this most expensive thing and how are we using it? And what can be a more efficient way that we can do it? Or your second most expensive thing. Scale out, like I mentioned earlier, is generally better than up. And we used to say this because the size of the machines you could buy on the cloud were just limited. There was a time when I think 32 cores was the most you could do, and it was like 448 gig of RAM, which, while a pretty powerful machine, not as big as you can buy on a server nowadays. But in general, having scale-out solutions is going to be more efficient because you're buying smaller components. It does make your application more complex. But especially for an application that you expect to grow over time, that's something you kind of want to design in from the beginning. And that's when we talk about these scale-out designs, we're typically talking about if you're building an application that you expect customers to use, less so if you're have one application that only is going to be inward-facing for your company. You're probably going to have less stress on it, so the design of that is less important. So making threshold decisions is a challenge. So, when do we decide we're going to re-architect? What's going to be the driver for that? These are typically made as a combination of money, performance, and reliability. Performance will drive them faster, in my experience, than the other two. Maybe not reliability, but in general, cloud reliability is pretty good anyway. Moving too fast is really dangerous. Like, there's a lot of things that can... You can do bad security things. You can spend too much money. You really want to plan. So being agile is good, but planning is also important. Not everything is possible for all applications. Things can get messy. Your application workload might be too busy. I mentioned that gambling customer that had 13 million transactions per second. There's no way they could have run that in any cloud. There's just not the hardware or the storage there that they would need to be able to pull that off yet. And it may or may not ever get there. And then try to be consistent in your decisions. And this kind of ties back into that governance thing. You'll be more cost effective if you're deploying things in a consistent manner and kind of setting your own standards. And the cloud does kind of a good job of putting things into boxes, so you don't necessarily have to design a standard. But if you have a standard set of policies and things like that, you can be more consistent and have a tighter control over what's going on, and that can be really helpful. All right, Gladys. I think we have some time for some Q&A now, and I see we have a couple of questions there. It would be great if anybody else, if you have any questions about what we talked about, or really anything related to cloud and architecture that you'd like me to try to answer, I'm happy to do it.
Right. We do have a bunch of questions already in the docket. And audience, we do want to remind you that if you have a question for Joey, anything he talked about in the session, please do throw that into the Q&A console right now, or as they come to you. And even if you don't have time to get all of these questions, we'll make sure to follow up with you afterwards. And Joey, I really want to start with this one from Tim. Why do you hate multi-cloud so much?
I think it's because I see organizations think they're going to do something that they're not. I think it kind of ties back to my, I want a globally available database that I can write to anywhere in the world and have it sync, which is like a very common executive ask. God, I just use ask as a noun. I'm sorry. It's a Microsoft-ism that I just caught myself in. But yeah, so that's a very common request where you'll want to have like a multi-cloud thing where we're going to write, we're going to sync, and there are a handful of organizations that can pull it off, but most organizations are not in that handful, even though they think they are, and that's something that's a concern of mine. There's a lot of things that can go wrong. Multi-cloud's a thing, and it's going to be a thing, and I think as long as you're using it intelligently, like, keeping your backups there, that can be a good solution.
Right. All right, next question. We have two from S. Lord. Their first question is, why are lift and shift costs so high? Are you referring to conversion costs or operating costs?
Yeah, so that would be operating costs. The conversion costs are generally pretty low. Like the migration, other than getting a bunch of data moved to the cloud, the migration for those is pretty straightforward. The ongoing operating costs tend to be higher for that kind of solution.
Great. And their follow-up question is a really great one. How much expertise do you need for a multi-cloud implementation? Do you need experts in each environment, or can you use a generic approach?
So that is a really good question, and it kind of gets to the crux of my feelings about multi-cloud. The organizations that really try to do it most effectively will try to use a genericized approach. Like you'll use Kubernetes because Kubernetes is effectively the same across the various cloud providers as your deployment mechanism. But the way you secure things and the way you network things in each of those clouds are specific, and you need to have that understanding there. And that's where it starts to get really tricky.
Right. Question here from Lloyd. How do you tell your board of directors our data will be safe in the cloud?
I point to the successful audits that the cloud vendors have. This is something that I think in the early days of cloud came up a lot more than it does now. I mentioned how there's a handful of organizations that can do multi-cloud effectively. There's also a handful of organizations that have better data center security than Microsoft, Amazon, or Google do. You're probably not in that handful. And yes, you can do stupid things in the cloud, and all you have to do is search S3 data breach, and you'll find lots of organizations that did dumb things. But in general, it's more secure. It's more secure than anything you have, and it's easier to implement a lot of security features in the cloud than it is on premises, because the cloud providers have made it that way.
That's a great question, though, and just as an aside before we get to the next question, it might be, I'm curious from the audience, how many of you would be interested in just an entire summit session on how to formulate an elevator pitch to your higher ups about trying to either update your cloud infrastructure or just develop a cloud infrastructure plan at all? It's a question we hear a lot from our readers on Redmond Mag, certainly, but once in a while we'll get a session question along those same lines, and I'm just curious if that's something that people would be interested in. Let us know if you have any ideas on that end, but that's a great question. Next one is for you, Joey, from Sudarshan. I apologize if I'm not pronouncing your name correctly, but they ask, what is your advice on storing sensitive data in multi-tenant public cloud model?
My advice would be to use encryption. There's really no other way. Depending on the nature of your multi-tenancy, that's something that I don't want to mess around with. And you want to use like a strong, I'm going to speak to SQL Server because they have a solution I know and it works really well called Always Encrypted. Oracle has something similar. I'm not as sure on some of the open source databases in terms of how they handle that encryption model. But in that case, basically the application holds the encryption key and even the administrators can't see the encrypted data. So that's what you really want for those sorts of solutions. Because yeah, PII fines are no joke, especially in the EU.
Right. That's good to keep in mind. We have another question here from S. Lord. Thanks again so much for the great questions, guys, by the way. This question says, what are the goals of a multi-cloud environment? For example, avoiding lock-in, disaster recovery, et cetera. And the main question is, are these objectives realistic?
Yeah, that's a really good question again. Avoiding lock-in is one I hear very commonly, and that's a bad one. Because that's not a realistic objective because you're going to have no matter how genericized you make your cloud environment, you're going to have dependencies on the cloud provider itself. That is something to keep in mind. Disaster recovery, I like the idea of not building out a full disaster recovery solution multi-cloud, but I'd rather, but maybe doing something like storing backups on another cloud. And you don't need to do this for everything because that's something that can be pretty expensive. But for your critical systems, sure, store your backups there. For the especially for the disaster recovery side, you're really better off designing around storing your data in multiple regions in one cloud provider, just because things like failover will hopefully be a lot easier in that model, and there's a lot less stuff that can go wrong.
Great. We have a question here from Jennifer. What are some of the challenges around asynchronous processing?
The big one is just it's different. You have to design it from the beginning. If you write an app to just make synchronous calls to a database, that's pretty straightforward. There's a lot of known examples of that. With a queue system like that, you have to interact with the queuing mechanism. You then have to have that queue cascade its writes down to the database eventually. There's just more moving pieces. Right.
And kind of a nice segue into Sudarshan's question. He said, what is your advice on data replication in the cloud? For instance, when do you use synchronous versus asynchronous replication?
So typically you're going to use synchronous for any traffic that's within a cloud region, even across availability zones. They're kind of designed for synchronous replication. And if you're not familiar with these terms, synchronous replication implies that you're waiting to acknowledge a write until it reaches the secondary copy, wherever that may be. So if you have a lot of latency there, it can impact the performance of your application. Asynchronous replication is going to be anything that goes across regions or across clouds.
Great. And we have time for just a couple more here. Let's see if we can squeeze in. From Edgar, he says, what are some of the drivers you've seen that lead to repatriating cloud workloads?
The biggest ones I've seen have been performance related. I know I talked a lot about cost and growing software as a service apps, but the ones I've seen mostly are where the cloud just can't meet the storage performance needs. And I remind you, I do a lot of work on kind of edge case database performance. So people that are in the 0.1% of their performance needs. So they just can't get enough storage performance even on the most expensive tiers of disk. So that is something I have seen a couple of times. But yeah, that's something the main driver. Cost, I think, in a larger organization is probably the more common one.
Great. And I think that's all the time we have left for questions. But thank you so much, everyone, for the great questions and queries and feedback. Joey, we do have, I think, a contact slide for you here.
Oh, sure.
If you want to, follow him on Twitter or get his pick his brain personally, please feel free to.
Yeah, I'm in full screen. So yeah, my contact info is up. Cool.
Yeah. So great stuff, Joey. Thanks for the presentation. Thanks, audience. And that's it for session 2. Please